Yes. Now our next part is prime numbers. So before we start this, let us revise the prime numbers. Prime numbers are the numbers which numbers have only two factors, one and the number itself. Means in short, what we say, that they never come in any other multiplication tables, that is multiples. They are not multiples of any other number. They are multiple of itself, right? So one and the number itself, only two divisors. So numbers having only two divisors are called prime numbers. And what about one? One is a unique number because it has only one divisor. Our definition of prime numbers is two divisors, and therefore one is a unique number. It is not prime. Remember well. So prime numbers start with 2. So 2 is the first prime number, single digit prime number, and it is the only even prime number, right? And then comes 3. 3 is the first odd prime number, single digit prime number. Okay, so like before less than 100 actually. From 1 to 100, there are 25 prime numbers. You have to learn all these prime numbers by heart. 25 prime numbers less than 100. Less than 100. So up to 100, there are 25 prime numbers, right? Then the numbers which do not have any common factor. All others are composite. What is the definition of composite numbers? They have more than two divisors, 3, 4, 5, and so on. Such numbers are called composite numbers, right? And now let us see which are the prime numbers. Now one digit prime number, there are 4. That is 2, 3, 5, 7. Then two digit prime numbers, again 4. Like that, we have to revise all them. We have to learn them by heart. Then only you can do this. Then comes co-prime numbers. What are co-prime numbers? They are not necessary that they are prime. Any two consecutive numbers are co-prime numbers because they do not have any common divisor, common factor. Two numbers which do not have any common numbers are called co-prime. Okay, you can consider 14, 15. Are 14, 15 prime? No. 14 is divisible by 2, 15 is divisible by 5. They have more than two factors, therefore they are not prime. But these two are co-prime because they do not have common factors. 14 has 2 and 7, this has 3 and 5. So no common divisor except 1. 1 is the common factor for all, right? And therefore they are co-prime. So these three things we have to remember. Prime numbers, composite numbers, co-prime numbers, and then comes twin primes. What are twin primes? Twin primes are the prime numbers which have only one composite number between them. Simple thing, 3 and 5. There is one number 4 between them is composite, and therefore this pair 3 and 5 is a twin prime, right? So like this, there are 8 pairs of twin prime numbers up to 100. Okay, I'll write them in fast so that you will remember. First is 3 and 5. Second is 5 and 7. See, in between there is 6. Then comes 11 and 13. Then comes 17 and 19. Then after that, 29, 31, 41, 43, then 59, 61, and 71, 73. So there are 8 pairs of twin primes. Remember them well, because we require these twin primes sometimes for solving few sums. Okay, so now let us solve sums. So here is our first question. How many two-digit prime numbers can be obtained having both the digits also prime? Both the digits also prime. Both the digits should be prime. See here, 17. Oh, sorry. 17. 17, this number is a prime, but here both the digits are not prime. 1 is not prime, right? And therefore, we have to find out such primes which have both the digits prime. Simple. For example, because their single digit numbers are eliminated, then these all 11, 13, 17, 19 all are eliminated because 1 is not prime. And then comes first number 23, which has both the digits prime, right? Then comes next is 37, then 53 and 73, right? Now think of others. Can you see any? It is very simple. Numbers should not start with, numbers should not end with any even, right? They should be odd. And just think of all the primes. Remember all the primes. Try to recall all the primes and then check whether both the digits are prime. So here are the these four prime numbers have both the digits prime, and therefore here our answer is C, 4 numbers, right? Let us see next. How many 2-digit prime numbers remain prime even after interchanging? Yes. So what we have to see after interchanging whether they remain prime. Now for that 2-digit number, so we'll start with first 2-digit prime, that is 11. If I interchange its digits, it will remain 11. So yes, this is one number. We got it. Then next comes 13. If I interchange the digits, it will become 31, and yes, it is prime. Okay. Then comes 17. If I interchange the digits, if it becomes 71, yes, it is prime. Then comes 19. What happens? 91. No, it is not. 91 is not a prime number. And therefore, here we got 3. Then let us see next. Now, one thing you remember. Don't consider those primes so starting with even, like 23, 43, 67, will not they? Because after interchanging, that digit will go to units place and then it will become even. So it will not be a prime, and therefore forget about that. So directly now, after this, we will go to 30 wala group, right? So in 30s, our first is 31, which we have considered here. 31 is over. Then next is 37. Yes. So if we change 37, interchange the digits, yes, it is a prime. Then 31, 37 over, 40 we will not take. Now 51. 51 itself is not prime. Then next take 53. It becomes 35. 5 comes in the unit place. So no, it is not. So 50s wala, 50, that group of 50s we will not cover. So 60 is also not possible. Then let us come to 70. So 71 we have done. 71 we have done. So that also covered. Then next is 73. That is also covered. So that group is also over. Then let us come to 80s. But 80s is not possible because 8 will go in the unit place. So that group was also we will not take. Then comes to next. That is, in 7's group there is 1. Yeah. See, this is 79. 79 is prime, and if you interchange, it becomes 97. This is also prime. So total there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 71. This is not there, sorry. 1, 2, 3, 4, 5, 6, 7, 8, and this is the only one number. And therefore 1, 2, 3, 4, 5, 6, 7, 8, and 9. So how many primes are there? 9 primes are there, which even after interchanging their digits, they remain prime, right? So our answer is C. Now let us move to next question. Okay. Find the sum of 2-digit primes ending with digit 1. So all we have to find out are the primes ending with 1. So first is 11, then 21 is not prime. So 31, then 41, 51 is not prime, 61, 71, and then 81 and 91, both are not prime. So we have to find the sum of all these. So just add them together. It will be 5 in the unit place, then 10, 20, 21. So the answer is, this was very simple sum, but only think of most of the time where you make mistake, 21, 51, 81, 91. These are all not prime. By mistake, if you take them, your answer will go wrong, right? And therefore, remember, these are the 5 numbers ending with 1, which are prime. Okay, so here the answer is 215, that is A. Let us move to next question. Now this is so simple. Which of the following is a pair of co-prime? Just now only I have told you that 2 consecutive numbers are always co-prime. So here just find out consecutive. How do we get consecutive numbers? Just by adding 1. 6 plus 1, 7. 6 and 7 are consecutive numbers. 10 plus 1, 11. 10 and 11 are consecutive. Similarly here, just find out. Now x and 2x, are they consecutive? No. And they have one common factor, that is x. Our definition, what definition says of co-prime numbers? They do not have any common number. Here they have common number x. Here they have common number x. Here also they have common number x. But there it is x and x plus 1. These two are consecutive numbers. Means they come one after the other. And consecutive numbers are always co-prime. So here answer is very simple. That is x and x plus 1. This is the answer. This was simple sum. Only don't get confused. See that there should be a difference of 1. If difference is 1, then they are co-prime. Okay? Okay. Chalo, let us move to next. Yes. While writing twin prime numbers less than 100. Just now only we have discussed twin prime numbers. Let us discuss them once again. And we have what we have to find out here in this question is which digit appears maximum number of times and how many times. Okay. So let us write all the twin prime numbers. So first is 3, 5. Then 5, 7. They are single digit. Then 11, 13. Then 17, 19. They are twin primes. Then afterwards it is 29, 31. Then 41, 43. Then 16, 59. It is 59, 61, and last is 71, 73. These are the 8 pairs of twin primes, right? Now let us see which digit appears maximum number of times. Let us start with 7. First option is 7. So 7, 1, 2, 3, 4 times. But is it maximum? Let us see. Then 5 comes only once, twice, thrice, 3 times. Then here it is given. So eliminate this option. This can be, but if there is no other digit which comes maximum time, then this will be the answer. Okay, this is not possible at all. Then 3. How many times? 1, 2, 3, 4, 5 times. Here it is given 9 times. So this option is also cancelled. So out of these 2 is the answer. So last digit remaining is 1. Let us find out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. This is the correct option. 1 appears maximum number of times, that is 9. 7 appears 4 times. So this is less number of times, and therefore 1 appears 9 times. This is the correct answer. Okay. So that's all for prime numbers. We'll meet in the next lecture.